be doing Dunman Secondary Paper 2. So, okay, A1. The list below shows the chemical formula of some compounds. And part A, they ask you to state one substance that is colored. Okay, when we see the word colored, right, immediately think of your transition metals. What's so special about transition metals is that they form colored compounds. Also, they have multiple oxidation states. Okay, so some of your examples will be iron. Iron can form Fe2 plus or Fe3 plus, or copper, Cu plus, Cu2 plus. Okay, so these are the two unique properties of transition metals. So one substance that is colored, I need a transition metal. I can put FeSO4, alright? So part B, state one substance that can be prepared by precipitation. Okay, when do we use precipitation? It is to produce soluble or insoluble salt. To produce insoluble salt. Okay, and also just a bit of revision. What are the reagents required for precipitation? I will need aqueous and aqueous reagents to produce an insoluble salt. When it comes to insoluble salt, right, there's only one method of preparation, which is precipitation. Okay, so I need to find an insoluble salt, which is silver carbonate. Remember, all carbonates are insoluble. So, except for my group 1 or SPA. Correct? Okay, part C. State one substance that is used as a catalyst in the cracking of bitumen into useful shorter fractions. Okay, this is memory work. This one is in the organic notes, organic chemistry notes. So cracking of bitumen. First, what is cracking? Cracking means the breaking down of long chain hydrocarbon into shorter chain alkenes, or even hydrogen. Okay, this is the meaning of cracking. So one of the catalysts used for cracking, right, is you can use either SiO2 or aluminium oxide. This one is in your notes. Okay? So part D, state one substance that reacts with both an acid and an alkali. Okay. One look, I know that this must be amphoteric. Alright? The definition of amphoteric means it can react with both acid and alkali. So amphoteric oxides, right? In your syllabus, you only need to know 3 of it, which is zinc, aluminium, and also lead. ZAP. Okay? So from the list, and one amphoteric oxide is aluminium oxide, Al2O3. Okay, part E. State one aqueous substance that produces a white precipitate that is insoluble in excess aqueous sodium hydroxide. Okay, this is a QA question, so you have to link this to your QA notes, the solubility, or not, the cation table. So, if you refer to your QA table, right, the answer will be CaCl2, sorry, your calcium ions. Okay, upon reacting with NaOH, I will form CaOH2, which is a white precipitate. Okay, and then it is soluble in excess, NaOH. Okay, so for A2, the table below shows the atomic structure of 6 particles represented by the letters A to F. Okay, the particles, they are either atoms or ions, and the letters are not symbols of the elements. Okay, when you see this kind of table, right, first thing, as long as you know the number of protons, always your first step should be identify the element. It will make your life a lot easier. And why do we use the number of protons? Because remember, every element has its own unique proton number. Okay, so let's identify what is particle A first. 15 protons. Your A will be phosphorus. 11 sodium. 19 potassium. 17 is chlorine and potassium. Okay, so now that I've identified the element, my next step would be to identify whether it is an atom or an ion. Okay, so how do we identify whether it's an atom or an ion? We compare the number of electrons and the number of protons. Why do I say that? Because remember, in an atom, the number of protons is equals to the number of electrons, correct? But for an ion, your number of protons will no longer be equals to the number of electrons, because I have already gained or lost electrons to form my ions, correct? So, which one is an atom? Is particle A an atom? I have 15 protons, 15 electrons. It is an atom. So, P atom. Okay, particle B. I have 11 protons and 10 electrons. It is an ion. So, what kind of ion is it? I have lost 1 electron to form a positive ion. Okay, then C. 19 proton, 19 electron, it is an atom. D. 17 protons, 18 electrons. I have gained 1 electron to form a negative ion. Then for particle E, is a atom. For particle F, atom. Okay, so whenever you encounter this kind of table, right, that has got to do with atomic structure, always follow these 2 steps. Especially identifying the element. It will really make your life a lot easier. Okay, so for part A, state and explain from the table which 2 particles are isotopes. Okay, what is isotope? The definition of isotopes are basically they are atoms of the same element with the same number of protons but different number of neutrons. Okay, again, same number of protons, different number of neutrons. Okay, so from the table, which 2 particles they have the same number of protons but different number of neutrons? It is C and F. Okay, so you need to state that for particle C, there is 19 protons and 22 neutrons, whereas for particle F, I have 19 protons and 20 neutrons. So there's 3 parts to it. First, you must state the definition of an isotope, and then next you answer the question which 2 particles are isotopes. Then you have to go into details about how many protons and how many neutrons they have to score the full mark. Okay? Then for part B, which 2 particles are part of a compound that is able to conduct electricity in both aqueous and molten state? Okay, first what factors do I need to fulfill in order to conduct electricity? This one is related to your chem bonding. Okay. In what cases can a compound conduct electricity? First, it must have there must be presence of charge carriers. Okay. So in this case, your charge carriers can be either positive or negative ions or electrons. Okay. The second condition that you need to fulfill is they must be mobile, able to move about freely to conduct electricity. So which compounds can conduct electricity in both aqueous and molten state? It can either be ionic compound or metallic compound. Correct? For ionic compound, in the aqueous and molten state, they can conduct electricity because okay, let me write down. This is just a revision for your chem bonding. So for ionic compound, right, in aqueous and liquid state, the strong electrostatic forces of attraction are weakened. Okay, so your oppositely charged ions, they are no longer held in fixed position, correct? So since they are no longer held in fixed positions, they are now able to act as mobile charge carriers. To conduct electricity. Okay? Then now for metallic bonding. Why can they conduct electricity? It is due to the presence of your sea of delocalized electrons. Okay? That is able to act as mobile charge carriers. Okay? Then recall for ionic compounds, right? In the solid state, it cannot conduct electricity. Why? Because in the solid state, the strong electrostatic forces of attraction will keep your oppositely charged ions held in fixed position, correct? So they are no longer able, they can't move about freely, so they are unable to act as mobile charge carriers. Okay? So this one is just revision. So back to the question, which two particles part of a compound able to conduct electricity? Okay, it must be an ionic compound. Because ionic compound is made up of a metal and non-metal. Correct? So two particles, one metal, one non-metal. It cannot be metallic bonding because metallic bonding is only for metals, and metals only one particle. Okay? Understand this part? So ionic compound, the answer would be B and D. Okay, this is where I say it is important to identify the element because it will make your life a lot easier. B and D, right? B and D. Na plus Cl minus. I know that it will form NaCl. Correct? So it makes your life very easy because you are able to identify compounds that are familiar to you. So NaCl is the ionic compound, and explain your answer. So same thing, using this explanation. Okay? Then for part C, okay, I'm going to erase this. Okay, part C, draw a dot and cross diagram to show the bonding between particle A and E. Let's see what's particle A and E. Particle A is phosphorus and E is chlorine. So A is phosphorus, E is chlorine. Okay, when it's in dot and cross diagram, right, the first step you should do is to identify what kind of bonding is it. Is it ionic bond or simple covalent bonding? Okay, so now let's see. Phosphorus and chlorine, they are both non-metals, correct? So non-metals and non-metals, they will form what kind of bond? Simple covalent bonds. Ionic bond is metal plus non-metal. Simple covalent is non-metal plus non-metal. Okay? So now that I've identified its simple covalent bonds, I can draw the dot and cross diagram. How do I draw it? Remember, for simple covalent compounds, right, it's about the sharing of electrons. Okay, whereas for ionic bonding, it is transfer of electrons. This type of question, right, it came out quite a lot of times for MCQ. They ask ionic bonds is transfer or sharing of electrons. So this is important. So don't get confused. Okay, so sharing of electrons, phosphorus, it forms an ion of P3 minus, correct? Because phosphorus is in group 5, so it forms an ion of P3 minus. Chlorine forms Cl minus. So how do I draw? 1 phosphorus and 3 chlorine. Correct? So phosphorus has 5 valence electrons. So 1, 2, and it will donate 1 electron to each chlorine atom, correct? Then now for chlorine is in group 7, so it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay? So this is how your dot and cross diagram will look like. Okay, so now for A3. An experiment was set up to determine the rate of diffusion of 100 cm3 of some gases. And okay, this table shows the gases that were being tested. So name and explain which gas diffused the fastest. Okay, when it comes to fastest rate of diffusion, right, how do we determine? We determine based on the MR. So the gas with the smallest MR will have your fastest rate of diffusion. Okay? Whereas if you have a larger MR, will have a slower rate of diffusion because it is so heavy. When it's so heavy, it takes a longer time to move, correct? As compared to a smaller MR. So, which gas diffused the fastest? Let's write down the MR for everything. Carbon monoxide, CO, your MR is 28, sulfur dioxide 64, CH4 16, nitrogen 28, chlorine 71, oxygen 32. Okay, so from this, which gas would diffuse the fastest? Which one has the smallest MR? It is my methane, correct? So methane, I've named it, so now I must explain because it has the smallest MR of 16. So it will have a fastest rate of diffusion. Okay, part B, explain in terms of kinetic particle theory. Why the temperature has to be kept constant in this experiment. Okay, so now you have to explain why temperature is a factor that affects your rate of diffusion. Okay, so it is because your temperature, it affects the kinetic energy of particles, correct? Okay. So at a higher temperature, particles, they will have a gain in kinetic energy and move faster and further apart. Correct? So why do we need to keep temperature constant? A constant temperature would ensure that particles have the same average kinetic energy. Okay? Or you can say a difference in temperature. It all means the same thing. Difference in temperature will result in particles moving at different speed so will lead to different rate of diffusion. Correct? Because the speed of your particles will affect the rate of diffusion. So if the temperature is not constant, right, it will be a very inaccurate experiment. Correct? Okay, so part C, name one gas in the table where this apparatus is unsuitable for finding the rate of reaction. Okay. Okay, let's look at the table. Let's look at the diagram. Okay, so how they test for these gases, right? The presence of water. Okay. So your gas is being collected here. So what is the factor that would affect how your gases are being collected? When it comes to water, right, you must take note that some gases, they may be soluble in water. Correct? So if they are soluble in water, do you think the gases can still be collected? No, correct? So which of these gases are soluble in water? The answer is sulfur dioxide. Okay, SO2, because it is a soluble gas. Okay, so A4. Okay, the leaf of this plant was crushed and mixed with an organic solvent. The colored pigments were extracted to give a dark green solution. Okay. Calculate the RF value for pigments X and Y. This is chromatography. Alright. So, chromatography, what is the whole idea behind chromatography? The more soluble the substance is in your solvent, the further it will travel. It will travel up your solvent, correct? Whereas the less soluble, it will travel a shorter distance. Okay? So, okay, RF value. How do we calculate the RF value? Okay, your RF value, right? Let's look at pigment X first. Pigment X is here. What is the distance that it has travelled? Here is 8.5 cm, correct? What's the distance between the distance travelled by X and your pencil line, your starting line? It is 8.5 minus 1, 7.5 cm. So now we compare it against the distance between your pencil line and your solvent front. Here is 11 cm, here is 1 cm. Don't forget to minus away the 1 cm. Okay, so here is 10 cm. So the R value for pigment X would be 7.5 over 10, which is 0.75. Okay, so this is for X. Then now for Y, my R value. Again, what is the distance travelled by Y? It is this, correct? So 5 cm. So the distance would be 4 cm. Again, I compare it to the difference between your solvent front and pencil line. So my R value will be 4 over 10, 0.40. Okay? So for part 2, the R values of different plant pigments based on scientific literature is shown. Identify what is pigment X and Y. Okay, this is easy. I just need to match 0.75. So my X must be chlorophyll B, and my Y 0.40, so it must be beta carotene. Beta carotene. Okay, so this one easy. Okay, part 3. Describe the principle by which separation of the pigments found is achieved using chromatography. Okay, for this, okay, so they're asking you for the concept behind chromatography. Remember just now we went through already. So the answer will be pigments are separated based on their relative solubilities in the organic solvent. That's not all, you must further specify the more or less soluble the pigment is, the further or shorter distance it travels up the chromatogram. Okay, you can also talk about R value. So in this case, right, the more soluble one would have a higher RF value, whereas the less soluble would have a smaller RF value. Okay, it's best to combine all this together. Okay, now for part B. Oxalic acid can also be extracted from the plant. What deduction can be made about oxalic acid from each of the following experiment? Part 1. 1 mole of aqueous oxalic acid reacts with 2 moles of aqueous sodium hydroxide. Okay, aqueous sodium hydroxide, it is my base, correct? Oxalic acid is a acid. So, one look, this is a acid-base reaction. Okay, then now let's zoom in. They say 1 mole of acid is required to react with 2 moles of base. So what does this mean? This has got to do with your basicity. So this implies that your oxalic acid, it is a dibasic acid. Okay, what does dibasic acid means, right? Okay, let's go through basicity. So for basicity of acid, I have monobasic and also dibasic. So what does monobasic means? Monobasic means one mole of acid will produce 1 mole of H plus ions. Okay? Whereas for dibasic, 1 mole of acid will produce 2 moles of H plus ions. So one example of monobasic, HCl, correct? HCl, it will produce only one mole of H plus ions, correct? Whereas dibasic, I can have H2SO4. H2SO4 will produce 2 moles of H plus ions. Okay? So now tribasic. One example of tribasic would be your H3PO4. So it will produce 3 moles of H plus ions. Okay, so this is the whole meaning behind, the whole concept behind basicity. Okay? So 2 moles of equals NaOH, right? Means I will need 2 moles of OH minus. So in order to react with 2 moles of OH minus, I would require 2 moles of H plus, meaning oxalic acid must be a dibasic acid. Okay, understand this one? Then for part 2, aqueous oxalic acid turns acidified potassium manganate from purple to colorless. Okay, there is a color change. Now, what is acidified potassium manganate? My KMnO4. What is this? This is a oxidizing agent. Correct? So if there's a color change, it means that my oxalic acid must be a reducing agent. Correct? Because oxidizing agents, they only react with reducing agent. It will not react with an oxidizing agent. So if there's a color change, it means that it has reacted with a reducing agent. Okay? For question A5, glucose reacts with excess oxygen to produce carbon dioxide and water in a process known as aerobic respiration. So they show you the enthalpy change and chemical equation for the reaction of 1 mole of glucose with oxygen. So this is the chemical equation. Okay, then I also have the enthalpy change. So part A, is the reaction exothermic or endothermic? How do I determine? I look at the sign of your enthalpy change, your delta H. Okay, so if it is positive, it is endo. If it is negative, it is exo. So in this case, it is negative sign, correct? So it is an exothermic reaction. So how do I explain in terms of bond breaking and bond forming? Okay, first and foremost, right, you know the formula for enthalpy change is the energy difference between bond breaking and bond forming, correct? Okay, let's talk more about bond breaking and bond forming first. Bond breaking, it's for I absorb energy to break bonds, correct? Make sense? Then for bond forming, I release energy, correct? So these two, right, are the concepts that you need to know. Bond breaking, I will need to absorb energy in order to break bonds, and then when I form bonds, I don't need that much energy, so I release out energy. So now that we know this, right, how we explain is the energy absorbed to break bonds in 1 mole of glucose, which is C6H12O6, and 6 moles of O2, okay, is lesser than the energy released to form bonds in 6 moles of CO2 and 6 mole of H2O. Make sense? So the energy absorbed to break bonds in my reactants, my glucose and oxygen, is lesser than the energy released to form bonds in my products. So if BB is lesser than my BF, my delta H would be negative. It will give me a negative value for enthalpy change. That's why there's a net release of energy to the surroundings. Okay, so for part B, they ask you to calculate the energy change for the reaction. Okay, for this, right, we have to use the, okay, let's read the question. So the question says, in a reaction, 150 cm³ of carbon dioxide was produced. So we're going to use this information to help us get the answer. So first, 150 cm³. I know that CO2 is a gas, correct? And so 1 mole is equivalent to 24 dm³. So 150 cm³, I must convert to dm³, is equivalent to how many moles? Okay, so the answer will be 0.00625 moles, correct? So now that I know here is 0.00625 mole, okay, what is the mole ratio of your glucose and CO2? C6H12O6 and CO2 is 1:6. Okay, so here is 0.00625 mole. The number of moles of glucose will be 0.001042 mole, correct? Okay, then now we look at the delta H. You see, delta H is minus 2300 kilojoules per mole. What does this mean? It means that for every 1 mole, okay, for 1 mole of C6H12O6 that reacts, it will release 2300 kilojoules of energy, correct? So 1 mole of C6H12O6 releases minus 2300 kilojoule. How about 0.001042 mole of glucose? It will release 0.001042 times minus 2300. So the answer will be minus 2.40 kilojoules. This will be my enthalpy change for the reaction. Okay? So next, part C. Draw an energy profile diagram for the reaction of 1 mole of glucose with excess oxygen. Indicate the enthalpy change and also the activation energy on the diagram clearly. So this is your typical energy profile diagram. And first we know that this is an exothermic reaction. So it means that your enthalpy change is negative, correct? So another thing to take note is your activation energy. It will always be positive. Okay? So now let's draw. For exothermic reaction, right? The energy level for your reactants is higher than the energy level for your products. So for reactants is C6H12O6 plus 6O2. Then for the products is 6CO2 plus 6H2O. Okay? Then now, what is the activation energy? It is this. Remember, activation energy is always positive, so it's always pointing upwards. So this is my EA. Then now, how about my enthalpy change? Enthalpy change is the difference between this, correct? Then, because it's negative, right? So my arrow will be pointing downwards. So I label delta H equals to minus 2300 kilojoules per mole. Okay? Okay, now part D. In another experiment, an aqueous solution of glucose was heated with alkaline CuSO4 solution And so a 1.44 gram sample of this oxide was found to contain 1.28 gram of copper. They ask you to calculate the empirical formula for this oxide of copper. Okay, when it comes to empirical formula questions, right? First, what is empirical formula? It is my simplest ratio. So for all empirical formula questions, you have to draw this table. So the first one will be you state what are the elements. Okay, so in this case, they say oxide of copper, meaning my elements must be copper and oxygen, correct? Okay, so the next one, I write the mass. For copper, they said it's found to contain 1.28 gram of copper. So 1.28. Then what's the mass of oxygen? They say 1.44 gram of sample contain 1.28 gram of copper. So meaning the mass of oxygen must be 1.44 minus 1.28, which should give me 0.16 gram. So 0.16. Okay, then next, I write down the AR. The AR of copper is 64. AR of oxygen is 16. Okay, then now I must find the number of moles. How do I find the number of moles? I'm using this formula. So whereby the number of moles is equals to your mass over AR. Okay, so the number of moles is 1.28 divided by 64, which should give me 0.02 and 0.01 mole. Okay, so now that I got all this right, my last step, I need the mole ratio. So how do I obtain the mole ratio? By dividing the smallest number. So in this case, which one has the smallest number of mole? It is my oxygen, correct? So 0.02 divided by the smallest number divided by 0.01, which should give me 2 and 1. So the empirical formula would be, because there's 2 Cu, right? And 1 O. So my empirical formula is Cu2O. Okay?